Yes, we are done with eighth question. Let's move on to the ninth. Yeah, the speed time graphs, these are the speed time graphs are given below. So the speed has been taken on y-axis and the time on x-axis you can see from the options. Which graph represents the case trolley decelerating? The first thing you should be able to see decelerating a constant speed. Of course, there should in the graph you should be able to see constant speed as well. Second one, constant speed, and then accelerating uniformly. These three things should be in the graph. So you can clearly see ninth one must be A. Yeah, ninth one must be A because speed with respect to time, it's actually reducing until here. Right? To here, this is decelerating, which means minus A minus A. Here it is constant speed. There is no change in speed. Obviously, acceleration is zero. And here it is acceleration. Speed is increasing. There is an acceleration. So uniform acceleration as the speed is increasing at constant rate. Okay. Speed is reducing. That is retardation minus A. Speed is constant. Acceleration is zero. And here you can see accelerating uniformly. So the right option is A only. I mean, first option. Here you can never see constant speed in this, and even there is no constant speed mentioned. Okay, so that is also fine. So the 10th question, let's see. You got displacement time graph. Displacement, it's okay. Yeah, displacement on the y-axis, the time on the x-axis, right? Then which among the following is correct? So until t naught, it is actually displacement is increasing there. So it must be a constant speed, constant velocity. Velocity is velocity is constant. Velocity is constant here until t naught. Then you can say displacement is constant. So it's not moving. Displacement is not changing means the object is stationary. Object must be stationary. Object must be stationary. Yeah. And here it is. Yep. It's given displacement. When displacement is reducing. So displacement is reducing means it must be again velocity is constant, right? So it is coming back to its original position, right? Displacement is actually reducing. until t is equal to time is equals to t naught, velocity is constant, and displacement increased and it is stationary. So it actually came back to the same position. Let's see, particle is at rest. No, the velocity of the particle increases up to t naught. Velocity is not increasing. Displacement increases. The velocity of the particle increases up to t naught. It's not velocity given. The particle moves at a constant velocity up to t naught and then stops. Yeah, somehow this is correct. And he hasn't talked about after b. So out of the options given, it, it's not about velocity. It's constant velocity. Out of the four options given, fourth is pulling. Let's move on to page number 113. This is page number 113. We want five, six, seven questions, starting from the fourth question. These are absolutely easy. Is possible we can solve them here. Right here. Let's see. Yeah, actually, right here. Let's see. Are initially at rest, which means u is equals with an acceleration. We got acceleration a and time in which it picks up velocity 72. Okay, this is meter per second. So this is the final velocity. So you can directly go with a is equals to v minus u by t. Right? What's the final velocity we got? Final velocity we got 72. The initial velocity has started from rest, so u is 0 divided by the time in which it picks up velocity 72. Acceleration was already provided, so the question is asking for t. Acceleration given is, so let me solve here the next step. So t is equals to, if you get this to t to that side, to here to denominator 2 by 4, definitely 18. Is it hours? No, seconds. 18 seconds. Yeah, got it. Yes, 18 seconds. So the right option is 18 seconds. That's so easy question. You should be able to do, the car is moving 16. So whatever the velocity given in the first part of the question must be considered initial velocity u. Cause it to stop. Cause it to stop means final velocity. You must take 0. Final velocity you must take 0 because it's stopped. So that there we can see the time given 3 seconds, the average deceleration, retardation. Retardation also same for acceleration is equals to V. So retardation, okay, acceleration is A, retardation means minus A. So let's find out A and then we will find minus A, retardation. A is equals to V is 0 minus U V is 60, V minus U by T, right? Time given in 3 seconds. So obviously A is equals to minus 20 minus 20 minus 20 minus 20 meter per second square, right? Minus 20, but we need average deceleration. So A is minus 20 means minus A is 20 second square. So the deceleration is 20 meter per second square. The right answer is here. So these are very simple, right? So is the question, most of the students can do these sort of questions effortlessly, but however, I told you that I'm gonna explain these questions on a video so that you can check on every time you want. Um, You can work on these questions again and again. You can watch the solution as many times as you want. So I just want to assist as such. So I'm solving these questions, although they are so easy. The cyclist pedaling at a speed, so initially given, so that must be initial velocity u picks up speed. Okay, this is nextly given, final velocity v over a distance. Okay, we got even displacement, so this acceleration v u s. So what's the equation you can see in terms of v square? V u s, that means v square minus u square is equals to 2s. It's a straight question asking for acceleration. So from the equation v square minus u square, a is equals to, please just write down v square minus u square divided by 2 into s. So v plus u into v minus u, right? V plus u is 50, v minus u. V square minus u square means v plus u into v minus u. V plus u, 10 plus 5, 15. V minus u, minus 5. So v plus u, 15. V minus u is 5, whole divided by 2 into the displacement given is 50, so 75 by 100. 75 by 100 acceleration. This is the acceleration, no? So 75 by 100 is 7.5, no, 0.75 meter per second square. Here, so this is the formula I have used. Just substituted given values in the equation. That's how you can get easy. So let's see, is it really difficult? If it is really difficult, solve on the paint plane. Okay. So particle starts with initial velocity 10 meters per second. So it's gonna be u, right? That's u. Moves with uniform acceleration, it attains velocity. Okay, this is v, 5 seconds. So you got t as well. U vt, right? Time taken by the particle from here onwards to 60. From there onwards, what's the time taken to get 60 meters per second? So question is the acceleration and out. So I'm thinking, what's the possible solution which takes lesser time? And first, we can actually find out acceleration directly. It's so cool. Once you get the acceleration of 30 meter per second, you can take 30 meter per second and initial velocity and 60 meter per second as final velocity. Just E is equals to V minus U by A. Yeah, it's the easy one. Yeah. Let me get this question on screen. Paint. It's giving unnecessary stuff as well. Let me cut it properly. God, we can't avoid it. So particle starts with initial velocity of 10 meter per second. Initially start U is equals to 10 second. Page number 113. This is the seventh question. And then moves with the uniform acceleration. Okay, it was clearly given throughout its motion. That's uniform acceleration. Okay. After some time, it is actually getting okay, 30 meter per second. 30 meter per second. The question is asking still what time is necessary, what time the object takes to get its velocity become 60 meter per second. So from here to here, of course, acceleration you can easily find it out because it was clearly given 5 seconds. So acceleration is a is equals to v minus u by t, right? V is 30, the final velocity. This is v, right? And this is u. Except initial velocity at t is equals to 0, all the velocities must be considered final velocity as per the necessity. That initially is 10. This change happened in 5 seconds. Obviously, 20 by 5, isn't it? 30 minus 10, 20 by 5. 20 by 5 means acceleration is 4 meter per second square, right? Got acceleration. Now just apply the same formula to the next portion of its journey. Okay. So acceleration is equals to v minus u by t. We know acceleration 4 meter per second throughout its journey. So let's substitute even for the second portion of its journey. Acceleration is constant, so you have to take 4 again, what we have actually found. The final velocity we require at here, final velocity is this one. Initially is 30, this one, because we want to know the time taken to increase its speed from 30 to 60 meter per second. So we have to take 60 meter per second final velocity, 30 meter per second initial velocity, the change asked, okay, the time taken for change in velocity from 30 meter per second to 60 meter per second. So the time taken is t, should be written as it is. That's what we have find. 60 minus 30 is 30 divided by 4. The time taken, 7, 4 sevens are 28, 4 fives are 27.5. It's time, no? So it must be seconds. So the time taken for the body to increase the speed from 30 meter per second to 60 meter per second is 7.5 seconds. As it is uniform accelerated body, to increase from 10 to 30, the time taken is only 5 seconds. To increase from 10 to 30, time taken is 5 seconds. Please observe from 30 to 60, it has taken 7.5 seconds. In the uniform accelerated motion, yeah, as velocity goes on increasing time to time, the time taken is going to be like this for the required changes in velocities. Cool. So let me see any other question requires. Yeah, even this question, eighth question should be what is now? Which option is correct? Let me mark it down. 7.5 seconds. Yeah, this is the 7.5 seconds. Let's do the next one. One. Let me select this question again. We'll get it on. Similar model was already done, right? So there T1 by T2. Here the total time was provided, has been provided. T1 plus T2 is equals to T. That's what we are going to approach this question. It's nice. Question: the car accelerates from rest as usual. Alpha is the acceleration A and reaches the maximum velocity as I told you, V max Vm and decelerate at constant rate. Once it reaches the maximum velocity, obviously it retards rate because in acceleration velocity goes on increasing when it starts reducing at that particular point its velocity is actually the maximum velocity. From the point it starts retardation, that particular point object has the maximum velocity. Constant rate beta, this is retardation minus A comes to rest. So if the total time lapse, for example, for acceleration it is T1, from deceleration for deceleration it is T2, T1 plus T2 is given T, then the maximum velocity acquired by the car. So standard question, so standard question. Solve this. So initially started from this, so I should take u is equals to 0 and it is accelerating A, it's accelerating, so acceleration let's take. At some point it has started retarding, then that's the point you can actually get maximum velocity Vm. It goes on increasing, that's why we say it's accelerating. At the point it started decelerating means that's the point it has the maximum velocity. Right, so from here onwards it's retarding, that is minus A, and after traveling it has come to rest, the final velocity is actually 0. So here it was mentioned alpha, the acceleration is alpha, minus say the deceleration is beta. Total time, so let's take this is T1, the time duration it has accelerated, T1, the time duration it retarded before it comes to rest is T2, right? So the total time was actually given T1 plus T2 is equal to T as per the question. So now, again the same, let's apply V is equals to U plus AT. So V is equals to U plus AT for the first portion. I told you you should be able to apply equations for each of the portions based on the details given. The first portion, so from here to here, we apply V is equals to U plus AT. U plus AT. So V is actually Vm. V is Vm. U is 0. Acceleration is alpha. The time I have mentioned that is T1. So from which I can write E1 is equals to Vm by alpha. Vm by alpha. Similarly, for the second portion, let me apply same equation. V is equals to U plus AT. For the second portion, U, this is going to be U, this is going to be D. So V is actually 0, U is VM. Here I got acceleration. You have to substitute here acceleration, not retardation. So minus A is B means A is going to be minus beta. So substitute minus beta over here. We can, this is T2, right? So from this, you can write T2 is equals to VM by beta. Right? We got T2 also. Now just substitute these two in this equation. T1 value VM by alpha, T2, VM by beta. So this VM by beta is equals to XT. The question is asking, what's the question is actually asking to find out? Maximum velocity. The question, this maximum velocity is how much? In terms of given parameters, given things. So yes, you can actually find it out. Let's get Vm common by alpha plus 1 by beta is equal to T. So I need Vm, right? So you can just go with Cm, beta plus alpha or alpha beta, alpha plus beta both are same. So just send what you have actually got now that side. Okay. So if you send this to this side, this quantity B, because I need Vm. So Vm should be alone one side, at one side, right? So that quantity, if you send this alpha by alpha, this side is equal, so it's going to become reciprocal. Whatever is beta both of these. So Vm into Vm is equals to alpha by this beta. Alpha plus beta into T. So see the option. This is the second standard question of the set questions. Okay. Any other models to continue discuss? Graph shows below speed. Speed and t, the relationship between speed and t is a kind of exponential decrement. Speed is decreasing exponentially. P square is equals to 2as. Yeah. Speed is changing. If it is uniform acceleration, speed must change at constant rate, but there is no such change. So it must be non-uniform motion. It should be like either like this. Yes. Or velocity and velocity is increasing like this, then obviously you have to say uniform acceleration. There's no such change you can see here, right? Okay. Speed or velocity. If the object is moving on a straight. Speed or velocity, that the graph between this, then we can say uniform acceleration. It is straight line, yeah. Uniform acceleration. This is not a parabola, no, it's not at all. One must be 4. Yeah, no. For displacement time graph is not possible. Displacement time graph. So here, displacement time, it's a uniform velocity. It's cool. It's correct. Displacement. Oh, time is not moving. Displacement is increasing. Can never become stationary, right? And time is some point. Okay, let's take it is not at t is equals 0. Some t is equals 0 is this one, no? This is the t is equals to 0. Yeah, there is some time t is equals to 1 or t is equals to some 4 seconds, 5 seconds or something. If you check. Here displacement is increasing, displacement is increasing. Time is not changing. So you never see a case where time is not changing. So this is wrong. You never see any case with time with no change. Always changes, right? Won't stop for anybody. So this is page number 113. Stop here.